Alright, so you're given this graph. Looks something like this. Right? You've got, this is a velocity time graph. Maybe I'll make it a little larger. There we go. So you got a velocity time graph that looks something like that. Velocity meters per second are the units being used in this case. And you've got, I'm going to immediately, I would encourage you to just get in the habit of stacking an acceleration graph below your velocity graph. So there's my acceleration graph, and the units I'm given are meters per second per second. Okay? So then, looks like my object moves with a constant velocity of 20 meters per second for 8 seconds. So that's 8 seconds there. And then it slows down for the next 12 seconds to a stop. Right? And so this is 20 seconds, right? And my acceleration graph, the whole point of stacking your graphs is so that they can correspond to each other. So I'm going to draw these nice, take my time, draw these nice vertical dotted lines at critical moments in time. Okay? And then I can do my acceleration graph. There's no acceleration up until 8 seconds, and then my acceleration is negative. So maybe I'll draw it like that. Okay? And if I look at the slope of my velocity graph from 8 to 20 seconds, so this is from 8 to 20 seconds, I'll be able to find the acceleration while the object is slowing down. So that's change in velocity divided by change in time. Final velocity minus, you know what? I kind of like using v2 minus v1. I'll do it that way. And then t2 minus t1. So v2, 0, that's velocity in the end, minus 20 meters per second over 20 seconds minus 8 seconds. And that's about 1.7 meters per second per 1 second. So this means every second object changes velocity, or in this case it's slowing down, by negative 1.7 meters per second. So like you're subtracting 1.7 meters per second from your velocity. So now I can proceed to figure out my velocity at 10 seconds, which would be, I'm just drawing it right there, because we need that to find the displacement from 10 to 20 seconds, which that's one of the questions being asked here. So what I'm looking at here is I gotta subtract 1.7 meters per second from each second that the object is traveling. So it looks like it's going to be going for 2 seconds before going from 8 to 10 seconds, right? So let's find our change in velocity. You can also find it right here, right? But that's my change in velocity from 8 to 20 seconds. If I want just my change from 8 to 10 seconds, I'm just talking about this little itty bitty thing, right? So that's my change in velocity from 8 to 10 seconds. So let's find that. So my change in velocity is going to be my acceleration times my time. Again, this is 10 seconds, this is 8 seconds, and this is 20 seconds. So my change in velocity is acceleration, which I just found is negative 1.7 meters per second squared times 2 seconds this seconds cancels with one of those, so I'm left with, what's 1.7 times 2? Would that be negative 3.3 here? So that means from, what is it, 8 to 10 seconds, object slows down by 3.3 meters per second. That's the change in velocity. So that's why it's negative. Okay? So that tells me that if I take 20 minus that number, right, that'll give me my velocity at 10 seconds. So velocity at 10 seconds is going to be my beginning velocity at 8 seconds. Whoa. My beginning velocity at 8 seconds, which is 20 meters per second, minus the 3.3 meters per second. Okay? So let's see what that is. Should be about 17 meters per second, right? It's close to 17. It's actually going to be a little less than that. I'll just punch in the calculator. I mean, it's going to be 16.7, I think. Let me just check that. Okay, so it's 20 minus 3.3. Yeah, so that's 16.7 meters per second. So that's the velocity at 10 seconds. So I'm talking about this number here. So I always go back and just label it on my graph. So now I can find this displacement really easily now. So I'll do that right here. So that displacement is going to be 1/2, since it's a triangle, right, times 16.7 meters per second times 10 seconds, 10 to 20 seconds, so that's 10 seconds. That's the base of that triangle. Okay, so that's basically 5 times 16.7. So 5 times 16.7 is about 84. 84, what, meters? Because these seconds cancel. So I just found the displacement from 10 to 20 seconds. Now, let's say I wanted to find the average speed, right? Do that down here. Well, that's going to be the distance traveled divided by the time taken. So I can just look at the total area under my velocity graph and not worry about positive or negative. So this rectangle, let's see that area first, okay? That displacement is going to be 20 times 8, 20 meters per second times 8 seconds. So 8 times 0, that's 160 meters. And then why don't I just do this triangle as well, that big one, okay? So I'll call that delta x1 and then delta x2. So there's two displacements. I'm going to add them together. So from 8 to 20 seconds is going to be 20 meters per second times 12 seconds, and I'm going to have to cut that in half because that's a triangle. So that's 10 times 12, basically. So that's 120 meters, right? So altogether, that's 280 meter total displacement, which is positive displacement, which means my object traveled 280 meters in distance. Okay? So 280 meters total displacement. Displacement and the distance traveled are not the same number when the object changes direction. Often displacement and distance traveled are a different number. In this case, you'll notice that the displacement is the same number as the distance traveled, but the displacement includes a positive direction. The total time taken is 20 seconds. So what's that? 14 meters per second. Put that in a calculator and you get about 14 meters per second. So that's an average speed overall. Speed from 0 to 20 seconds. Anyway, I hope that helped. That was one of the problems from Friday. I thought I'd put a screencast up so you could check your work. Have a good day.